We will now go to the gentleman from Florida, Dr. Dunn.
Thank you very much, Mr. Chairman. I'd like to turn our attention to some of the life sciences that NASA gets involved in. In the 18 appropriations bill, as marked up in the committee, we inserted a provision for NASA to spend at least $10 million on life detection technology. Can you explain briefly, whoever's the right person here, for what are we using for life detection technology? Maybe tell me a little bit about how that compares to the older and what we're developing. Briefly, 5 minutes.
Why don't I get started? So part of the life detection technologies are actually the type of technology we already talked about here. So it's basically star shade, it's coronagraph technology, as well as other promising approaches that would really help us to actually collect a spectrum and kind of the type that was shown here by Dr. Mountain, you know, like a spectrum that would help us kind of read, if you want, a fingerprint of life elsewhere. And so it's that kind of technology that we're currently investing in and are committed to doing so in the future.
All right, so life takes some pretty surprisingly different shapes and forms. Can be a little hard for us right here on Earth to decide what is life and what isn't life. And I wonder if we are needlessly or unnecessarily limiting the search for the type of lives we might find on an exoplanet.
I think it's a really hard question you're asking. Kind of what we know about life is what I would always talk kind of in science language as an n=1. So we have exactly one type of life and many variations thereof. And so basically what we're doing as scientists, you know, and there's people who are scholars in this, perhaps even at this table, what we're doing is we're going the other way and really asking, what does the universe provide us with? You know, kind of from, in many cases, basic principles, kind of early universe, but how stars work, what are the building blocks, and how can life, what would be the principles that we would be using from these building blocks that basically would actually create signatures kind of in many different scenarios that are actually different than ours, that we could really see. So it's not so much how exactly what life does, but what life is, but what life does on an atmosphere and so forth.
That's good. So can you explain why it is to the public in general? Why are we so fascinated with looking for life? And I don't want an essay answer here. Have you got a sound bite for me back home?
For millennia, we've wondered where our origins come from. You know, are we alone? I mean, for 4 billion years, we've looked up at the sky and wondered, are we alone? And that loneliness may come to an end if we discover that we are no longer alone. That would change the way we think about biology, change about our civilization. And if we find nothing, think how precious this planet is.
So one of the ways we can spend some of this $10 million is on looking for life on Mars with whether manned or unmanned missions we send there. I know we've done that in the past. I know that the answers have been cloudy, murky, but I think there's ways to rather inexpensively clean up those experiments and rerun them with several Mars landers that are coming right at us. Because of the time, I'm going to skip to the next question. So there's we've proposed 4 telescopes here, gentlemen. So why 4? Why do we need 4 different scopes to look at the exoplanets?
I just want to make sure, I assume you're talking about telescope studies for the future, the 4?
Right, yeah.
So my full expectation is that through the academy process, a prioritization will come. So by us focusing on 4, basically what we hope to do is provide a set of options for the academy to really put the pieces together and actually really see what's possible, kind of really translate kind of, if you want, scientific aspiration into some engineering language and help from that, based on the scientific knowledge we have at that point during the decadal.
Are you telling me you might cut down to launch less than 4, launch 1, 2, 3?
The 1 will be the first one. Out of the 4. Will not do 4 at the same time.
Oh, I understand. I mean, which it seems funny to be planning for 4 all at once. So, and in the few seconds left to us, why are we launching the James Webb on the Ariane? I understand the cost things. Is it just cost? Why are we using a European missile rather than a good old-fashioned American rocket?
It's a really good question. I already promised to submit that answer for the record and really go through the history of this. I told you what I know from that.
So good, yeah, and so I'm a physician. I'd love to get involved with you guys in your life science, your proof of life, if you will, on whatever planets we land on. And I yield back. Thank you very much.